This is given to be a one-to-one function, so let's graph this function, then we'll graph its inverse. Let's just find intercepts. For example, if x is 0, f of x or y is negative 14, so I'll have the ordered pair 0, negative 14, and I'm going by 2's here. So 0 left or right, 2, 4, 6, 8, 10, 12, 14. Let me write this down for you. X is 0. F of x is negative 14. How do we find the x-intercept? We let y or f of x be 0. If you let f of x be 0, add 14 to both sides, and then I think you can see divide both sides by 7, and x is 2. So we have the x-intercept. This is 2, 0. You can plot more points, but that's enough for me to graph my function f of x. So this is the graph of f of x. Now remember how the graph of a function and its inverse are related. If it were possible to write down every single ordered pair solution of this function, all I need to do is switch the coordinates and I'll have ordered pairs of the inverse. So in other words, 2, 0, that's an ordered pair solution of f of x. I know 0, 2 is an ordered pair solution of its inverse. So I can plot that point as a point of the inverse. Also, I know 0, negative 14 is a point of the function. So what is a point of the inverse? Negative 14, 0. So let's see. 2, 4, 6, 8, 10. I will extend this a little bit. Get 12 and 14 here. 2, 4, 6, 8, 10, 12, 14. And this will have coordinates negative 14, 0. Notice I just switched the coordinates. Here, then, is the graph of the inverse through these two ordered pairs. And I can call this graph, to let everybody know that this is the inverse, I can call this f inverse of x. And I want you to see that these two graphs are symmetric across the line y is equal to x.